Hi, welcome back to my class in Advanced Statistics. For today, we will take up expected value for a discrete random variable x or mathematical expectation for a discrete random variable x. But before we go into that, we will have one last example for constructing the probability distribution for a discrete random variable x. So consider the following problem. Three administrative assistants are ranked by the Chief Executive Officer or CEO, Chief Executive Officer of a corporation according to the CEO's opinion of their administrative skills. Let capital letters A, B, C denote the three assistants. Let X be the number of assistants who are ranked ahead of assistant A. Find the probability distribution for X. What is the probability that the CEO ranks only one assistant higher than assistant A, and at least one assistant higher than assistant A? The variable x defined in this problem for the number of assistants who are ranked ahead of assistant A is what is known as a discrete random variable. It is a discrete random variable because the number of assistants who rank ahead of assistant A can be obtained by simply counting the number of assistants who rank ahead of assistant A. And in this problem, we will construct the probability distribution for the discrete random variable x. If you remember, in the last lesson, we had an example where we used combination, and we are given 6 small appliances, 2 of which are defective appliances. And the customer chooses at random 2 of the 6 small appliances. And we let the discrete random variable x be the number of defective appliances among the 2 chosen and purchased by the customer. And to find the number of ways of choosing 2 appliances at random from the 6 small appliances, 2 of which are defective, we made use of combination because the arrangement of the 2 appliances chosen and purchased is not important. That is, the order of choosing the 2 appliances is not important. But in this particular problem, order is important because the 3 assistants denoted by capital letters A, B, C are to be ranked. And the order of this, the order and ranking of these assistants in an arrangement will denote their rank. Again, the order of these 3 assistants in an arrangement will indicate or denote their rank. So first, we find the number of permutations or arrangements of the 3 assistants A, B, C. And we use the permutation because in permutation, order is important. In the arrangement of distinct objects, order is important. Thus, we find the number of arrangements of the 3 assistants A, B, C by permutation. And it is given by the following formula. find the number of arrangements of the three assistants, we use the permutation case 1. Permutation case 1 refers to the arrangements of n different objects or n distinct objects taken all at a time. And definitely these three assistants are all distinct and different. So we apply case 1, where the number of arrangements of n distinct objects taken all at a time is given by n factorial. In our example, n is 3 for the 3 assistants to be ranked. And 3 factorial, by definition of factorial, is 3 multiplied by 2 multiplied by 1. Or you can use your calculator to calculate 3 factorial. But by expansion, 3 factorial is 3 multiplied by 2 multiplied by 1 equals 6. So we have 6 possible arrangements or ordering of the 3 assistants ABC. And we list these 6 permutations of ABC or arrangements of ABC as our events. One possible arrangement of the 6 arrangements is ABC. ABC. In this arrangement, A comes ahead of B, which means that A is ranked first, B is ranked second, and C is ranked third. And we are interested in the values of the discrete random variable x for the number of assistants that rank ahead of assistant A. Since A is ranked first in this arrangement, x is 0. The number of assistants that are ranked ahead of A is 0 because A is, in this arrangement, is ranked ahead of the 2 other assistants. Another possible arrangement from the 6 arrangements is ACB. Now, this arrangement is different from the first arrangement, although they have both A in the first order, but the ordering of B and C makes the difference between these 2 arrangements. In the first permutation, B is ranked ahead of C. In the second permutation of ABC, C is ranked ahead of B. So these 2 permutations or arrangements are different. Now, the value of the discrete random variable x for this particular arrangement of ABC again is 0. Because A is ranked ahead of the other 2 assistants and x is the number of assistants who are ranked ahead of A. Therefore, x is 0. Another arrangement of the 6 possible arrangements is given by BAC. In this arrangement, B is ranked ahead of A, and A is ranked ahead of C. Hence, the value of x, the value of the discrete random variable x for the number of assistants who are ranked ahead of A is 1. And that one assistant who is ranked ahead of A is assistant B. Another arrangement of the 6 from the 6 possible arrangements is BCA. In this arrangement, B is ranked ahead of C, C is ranked ahead of A. Now, the value of the discrete random variable x for the number of assistants who are ranked ahead of A for this particular arrangement is 2. Because B is ranked ahead of A and C is also ranked ahead of A. So these two assistants B and C are ranked ahead of A. Therefore, the value of the discrete random variable x is 2. Another possible arrangement from the 6 possible arrangements of ABC is given by CAB. In this arrangement, C is ranked ahead of A, but A is ranked ahead of B. But we are interested in the number of assistants who are ranked ahead of A. And only C is ranked ahead of A, thus the value of the discrete random variable x is 1. And now we have 1, 2, 3, 4, 5 arrangements of ABC. The last arrangement of the 6 possible arrangements is CBA. In this arrangement, the assistants C and B are ranked ahead of A. So there are 2 assistants who are ranked ahead of A, assistants C and B. Thus, the value of the discrete random variable x is 2. Now, these events are equally probable, or they are equally likely to happen or to occur. And there are 6 possible events. Thus, the probability of each event, if they are equally probable or equally likely to happen, is 1 over 6. The probability that this event will occur, ABC, where the value of the discrete random variable x is 0 is 1 over 6. The probability that the CEO will rank the 3 assistants in this order, A, C, B, has the same probability of 1 over 6. This is 1 out of 6 possible events. So the probability of this event ACB is 1 out of 6. And this 1 over 6 is the probability that the number of assistants that are ranked ahead of A is 0 for the arrangement ACB. For the arrangement BAC, where only 1 assistant is ranked ahead of A, thus the value of the discrete random variable x is 1. The probability that x is 1 for this particular arrangement of 3 assistant ABC. For this arrangement BAC, the probability that the discrete random variable x is 1 is 1 over 6. And the same for the remaining events, the probability of each event, the probability of this event where the value of the discrete random variable x is 2 is 1 over 6. And the probability that the value of the discrete random variable x is 2 corresponding to this arrangement of the 3 assistants CBA is also 1 over 6. Now we summarize this table into a more compact table, and we will call it the probability distribution for the discrete random variable x, the number of assistants who are ranked ahead of assistant A. From this table, you can see that there are 3 possible values of the discrete random variable x, and those are 0, 1, and 2. And the value of x equals 0 can occur in two ways, either in this event or in this event. Thus, the probability that x is 0 is equal to the probability of getting this event ABC, which is 1 over 6, plus the probability of getting this event ACB with the same probability of 1 over 6. Hence, probability x equals 0 equals 1 over 6 plus 1 over 6, which is 2 over 6 or 1/3. Now, the probability that the value of the discrete random variable x is 1, the value of x equals 1 can occur in two ways, in two events. For the event BAC and for the event CAB. Thus, the probability that the value of the random variable x is 1 is equal to the probability that x is 1 for this event BAC, which is 1 over 6, plus the probability that x is 1 corresponding for this event CAB, which is also 1 over 6. Thus, the probability that x is 1 equals 1 over 6 plus 1 over 6, or 2 over 6 or 1/3. And the last possible value of the discrete random variable x is 2. And x is 2 can occur in two ways. Either you get this event, the chief executive officer ranked the three assistants in this order BCA, or the chief executive officer ranked the three assistants in this order CBA. So the probability that the value of the discrete random variable x is 2 is equal to the probability that x is 2 for this event BCA, which is 1 over 6, plus the probability that x is 2 for this event CBA, which is 1 over 6. Or the probability x equals 2 equals 1 over 6 for this event plus 1 over 6 for this event. Or 1 over 6 plus 1 over 6 is 2 over 6 or 1/3. Now, this is now the probability distribution for the discrete random variable x, representing the number of assistants who are ranked ahead of assistant A. And after you have constructed the probability distribution for the discrete random variable x, you check these two properties that must be satisfied by the probability distribution. First, the probability of the discrete random variable x is greater than equal to 0, less than equal to 1. That is, the probability of x cannot be more than 1 and it cannot be negative. And since all these probabilities, 1/3, 1/3, 1/3 are all greater than 0, but less than 1, this first condition is satisfied by this probability distribution for x. The second property of probability distribution is that the summation of the probabilities corresponding to the values of the discrete random variable x is 1, where x here is 0 to 1. So we check. The summation of these probabilities P of x equals probability x is 0 The summation of the probabilities P of x is equal to probability x is 0. The values of x is from 0 to 2. Hence, the summation of the probabilities equals probability x is 0 plus probability x is 1 plus probability x is 2. And the probability that the value of the discrete random variable x is 0 is 1 over 3. Plus the probability that the value of the discrete random variable x is 1 over 3. And the common denominator is 3. So we add the numerator, 1 plus 1 plus 1 is 3 over 3. And 3 over 3 is 1. Thus, the second condition of probability distribution is satisfied by our probability distribution for our discrete random variable x, representing the number of assistants who are ranked ahead of assistant A. Therefore, this probability distribution is correct. We now define mathematical expectation for a discrete random variable x. Mathematical expectation for discrete random variable. Let x be a discrete random variable with probability distribution P of x. The expected value of x, or population mean, denoted by mu equals E of x, is given by mu equals E of x is equal to summation of the products x times P of x. Now, the definition says to calculate the expected value or the mean of the values of the discrete random variable x, we need to know the probability distribution for the discrete random variable x. That is, we know the values of x, the possible values of the discrete random variable x, and the corresponding probabilities for the probabilities corresponding to the values of the discrete random variable x. Because to calculate the expected value of the discrete random variable x, or the mean of the discrete random variable x, we need to multiply the value of x by its corresponding probability. And we do that for all values of x, and then we add the products for the summation. That is, we get the summation of x and P of x over all values of x. That's why the index here is x. And the expected mean, the expected value or population mean or mean of the discrete random variable x is denoted by the Greek letter mu. This is the Greek letter mu, or the expected value is denoted by E of x, capital E for expected value of x. This means that if you will repeat the experiment many times, what do you expect to be the average value of the discrete random variable x? And that is the meaning of the expected value of x, or the mean, population mean of the discrete random variable x. In the previous lesson, if you recall, we had an example of tossing two balanced coins. We take that example as our first example for mathematical expectation. Recall the example on tossing two balanced coins. If you can recall, we enumerated all the possible outcomes of tossing two balanced coins. Those are, you get two heads, one head in the first coin, one head in the second coin. Or HT, head in the first coin, tail in the second coin. Or TH, tail in the first coin and head in the second coin. Or two tails, we get tails in both coins. And our discrete random variable x for that example represents the number of heads in the two balanced coins. And we obtain the following probability distribution for the discrete random variable x representing the number of heads when two balanced coins are tossed. The possible values of x are 0, that is you get no head when you toss two balanced coins, and the probability that x is 0 is 1/4. The event where x is 0 is the event of getting tail in the first coin and tail in the second coin, and the probability of that event is 1/4. Another possible values of the discrete random variable x is 1, and the probability that x is 1 is 1/2. There are two events where you can get one head. These are HT, head in the first coin and tail in the second coin, or TH, tail in the first coin and head in the second coin. So you have 2 out of 4 possible events. 2/4, or in lowest terms 1/2. And the last possible value of x is 2. You get two heads when you toss two balanced coins, and that is the event HH, head in the first coin and head in the second coin. Now, if you will toss the two balanced coins 1,000,000 times, what is your expected value for the discrete random variable x representing the number of heads? Or if you toss the two balanced coins 1,000,000 times, what is the average or the mean of the values of the discrete random variable x? And we calculate that using mathematical expectation for discrete random variable x. And this is the formula. The expected value for discrete random variable x, denoted by the Greek letter mu, or by this notation, expected value of x is equal to the product of the value of x is equal to the summation of the products of the values of x and their corresponding probabilities. We multiply the value of x by the corresponding probability. The first one is 0, multiplied by its corresponding probability, 1/4. The sigma notation for summation indicates the operation addition. So plus 1 multiplied by 1/2 plus 2 multiplied by 1/4. 0 by 1/4 is 0. 1 multiplied by 1/2 is 1/2. And plus 2 multiplied by 1/4 is 2/4. In lowest terms is 1/2. And 0 plus 1/2 is 1/2. And 1/2 plus 1/2 is 1. This is the mean of the discrete random variable x, or the expected value of the random variable x, representing the number of heads when tossing two balance coins. And what does this mean? It means that if you will toss the two balance coin many times, such as 1,000,000 times, then the average of the values of the discrete random variable x, or the mean, is 1. Or if you toss the two balance coin 1,000,000 times, many times, then you can expect the value of the discrete random variable x for the number of heads to be 1. You can expect to get a 1 head if you, on the average, if you toss two balance coin many times. Before your exercise, let us go back to our first example on the three assistants denoted by ABC that were ranked by the Chief Executive Officer. And we have constructed the probability distribution for the discrete random variable x for the number of assistants who rank ahead or higher than assistant A. And the possible values of the discrete random variable x are 0, 1, 2. And these are the corresponding probabilities. X equals 2, the number of assistants who rank ahead or higher than assistant A is 2. The probability is 1 over 3. Now we answer this question. What is the probability that the CEO ranks only one assistant higher than assistant A? In the first part of the question, we are asked the probability that the value of the discrete random variable x is 1. That is, only one assistant is ranked higher than assistant A by the CEO. That is the probability that x equals 1 from our probability distribution table for the discrete random variable x. If x is 1, the probability x is 1 is 1 over 3. In the second part of the question, we are asked what is the probability that the CEO ranks at least one assistant higher than assistant A. In symbols, we write that what is the probability that the value of the discrete random variable x, representing the number of assistants who are ranked higher or ahead of assistant A, is greater than or equal to 1. And the possible values of x that satisfy this condition, x greater than or equal to 1, are 1 and 2. So the probability that x is greater than or equal to 1 is equal to the probability that the number of assistants that rank higher than assistant A, that is, probability x is greater than or equal to 1, is the same as the probability x equals 1 or x equals 2. The probability that one assistant rank higher than assistant A, or the two assistants rank higher than assistant A. And for this word or, we use the union. And to find the probability of the To get the union of these two probabilities, we use the addition property of probability. The probability that x is 1 or x is 2 is equal to probability that x is 1 plus the probability that x is 2. That's by addition property of, that's the addition property for probability. And from our probability distribution table, the probability that only one assistant is higher than assistant A, x is 1, probability x is 1 is 1 over 3. Plus the probability x is 2, two assistants rank higher than assistant A, x is 2, probability x is 2 is also 1 over 3. Common denominator is 3. We add the numerators. 1 plus 1 here is 2. Thus, the probability that at least one assistant is ranked higher by the CEO, higher than assistant A, is 2 over 3. And the probability that only one assistant ranks higher than assistant A is 1 over 3. The probability that 1 or 2 assistants or at least one assistant, x is greater than equal to 1, ranks higher than assistant A is 2 over 3. For your practice, please try the following exercises. Number 1, a recent survey shows that those entering a 1-year training program for aircraft flight controllers, only 1 in 2 complete the program. Suppose that 3 individuals are enrolled in a training program for aircraft flight controllers. Find the probability distribution for x, the number who complete the program. This problem is a problem on probability distribution for discrete random variable x. In this particular problem, the discrete random variable x represents the number of individuals who complete the program. And the problem says that only 1 in 2 individuals who enrolled in the training program, 1-year training program for aircraft flight controllers, complete the program. Suppose that there are 3 individuals who enroll in this 1-year training program for aircraft flight controllers. You are asked to find the probability distribution for the discrete random variable x, the number of individuals who complete the 1-year program. Number 2, a random variable x has the following probability distribution. These are the values of the discrete random variable x. The values range from 0 to 5, and their corresponding probabilities are also given in this table. When x is 3, when the value of the discrete random variable x is 3, the probability that x is 3 is 0.15. When x is 5, the probability that the value of the discrete random variable x is 5 is 0.05. Letter A, find the expected value of x. That is, you will compute the mean denoted by the Greek letter mu, or E of x, or expected value of x. Letter B, graph P of x and locate mu on the graph. Here you will construct the probability histogram where you write the values of the discrete random variable x in the horizontal axis, and you select a scale for the probabilities in the vertical axis. And you locate mu. the expected value of the discrete random variable x in the probability histogram or graph of p of x. And letter C, you answer this question: does mu, the expected value of x, fall near the center of the probability distribution? And this number 2 problem is a problem on mathematical expectation for discrete random variable. In the next lesson, we will have problems. We will solve problems for the applications of mathematical expectation for discrete random variable. If you have question about the lesson today, you ask your question in the comments below. And do not forget to subscribe to my YouTube channel, Art Kalisan, the channel of learning and leisure. Or you may ask your friends and classmates to subscribe to my YouTube channel, Art Kalisan, so they may learn as well. Thank you for joining me in my class today.